So yesterday we talked about the long division process for polynomials. Today we are shifting to the synthetic division process. It provides us with a simpler version of dividing, but it only works if we are dividing by linear expressions. Something like x minus 5, x minus 2, x plus 7. All right? Linear expressions like that where it's x minus a. For those division questions, you can go through it synthetically. The process says to write down the coefficients, including zeros. So remember yesterday we said if you were missing any terms, you should put a 0 in there? What that did with your long division process was it made all of your terms line up. So you had like terms in each column, and you could subtract correctly. If you don't put the zeros in there with long division, you end up with maybe missing a column and you're trying to put a number in there, and there's nothing to match it with. Okay? It makes the subtraction even harder than it already is. With synthetic, there's absolutely no way to get the right answer if you don't put zeros in. They have to be there. Because what we're going to do is we're going to take out all the variables and all of those exponents. All we're going to have is just plain numbers in our pattern. Okay? And so we lose the context of what that was. For example, if I said, here's my number, and I don't put the 0 in there, it looks like this. Those are two different numbers, right? So if I gave you a 3x squared plus 7, and I took out the variables, it's going to look like that. When in fact, it was 3x squareds, no x's, and a 7. Does that make sense? It's kind of like your place value columns. You need a column for each term. So it is critical that you include those zeros. So we're going to take out our variables and our exponents. We're just going to deal with those coefficients. It says for the divisor, you want to reverse the sign. So yesterday with long division, we would have put our x minus a out front. Yes? Today, with our division, we are going to see it like this. It's going to be an upside down division bar. And instead of kind of the angle on the front, it's usually just a straight line. And instead of putting x minus a, we're just going to put a. By doing that, we can add our columns instead of subtracting, which is much easier for students. Okay? All right, so let's get rid of this. It says, use synthetic division to take x cubed minus 14x squared plus 51x minus 54 and divide it by x plus 2. So first of all, I look and say, yep, I have a linear divisor, which means I can do this synthetically. If my divisor is x plus 2, what am I going to put out front? A negative 2. Okay? X plus 2 is really x minus a negative 2, right? So that negative 2 is what goes in front. Okay? Now we're going to take our coefficients. So I'm going to look at my polynomial and check. Am I missing any terms? I have cubes, I have squares, I have first powers, and I have constants. I'm good. I'm going to take those numbers, and each number is going to go in a different column in order. So my cubes go first. I have one of those. I have negative 14 of my x squareds. I have 51 of my x's, and my constant is negative 54. Are there any questions of how I set it up? Okay, I want you guys to put your pencils down. I will pause the recording and give you time to write this down in a minute, but I do want you to be watching because I'm going to be pointing to things and telling you where you need to write something, and I need you to have your eyes up here. All right, So to do the synthetic process, we bring down our first number. In this case, it's a 1, so I'm going to bring it down. It's going to go underneath my bar. Okay? And notice that I left some blank space right above the line. All right? I'm going to be putting numbers in there. We then multiply these two together. So I'm taking negative 2 times a 1. I get negative 2. That number gets written up here. And then I'm going to add my column. So I add these two together. I end up with negative 16. And I keep repeating that same process. So I multiply the negative 2 with the negative 16. That gets me 32. I write it in the next column. And I add my column down. Multiply again. Negative 2 times 83 is negative 166. Adding it with the negative 54 is negative 220. Okay? Questions about the process? We'll do several of these today, so don't worry if you're not quite sure yet. How do we interpret our answer? The last number we get will always be the remainder. Okay? Sometimes it'll be 0, sometimes it'll be a positive number, sometimes it'll be a negative number. Last number is always remainder. Working backwards, the next number in my answer would be my constant. The next number back would be my x's. The next would be my x squareds. That means the quotient, which in our long division process would have been at the very top of our problem, right, above the division bar. Okay, this is now my quotient. 1x squared minus 16x's and a constant of 83. And the remainder, which we always write as a little fraction, the remainder is negative 220. I'm trying to divide by x plus 2. It's just too small. Okay? Always check to see if it makes sense. A lot of kids forget that the last number is your remainder and they picture that as the constant. When you go back, you were told to take an x cubed and divide it by an x. What's the biggest thing you're going to get? An x squared. Does your answer start with an x squared? Does that make sense? Okay. I'm going to pause the recording, give you guys some time to write this down, and then we'll continue. All right, moving on to our second one. It says, use synthetic division to divide x cubed minus 57x plus 56 by x minus 7. Again, we have a linear divisor. What's going to go in front? A positive 7, okay? Another way to look at it is what makes it 0. All right? Can you picture a 7 making that 0? Now, looking at the polynomial we're trying to divide, do we have any missing terms? Which one? So there needs to be a 0 in between those two. We have no x squareds. So my coefficients, 1 for my x cubes, 0 for my x squareds, negative 57 for the x's, and 56 for the constant. Okay? Our process again, we start by bringing down our very first number, and then we multiply. 7 times 1 is 7. Our answer goes in the next column. And then we add. Adding down gets me a 7. Multiplying. 7 times 7 is 49. What do we get when we add? Negative 57 plus 49. Negative 8. All right? Multiplying. 7 times negative 8. And what do we end up with? 0. What is that? That position, the last number is the remainder. We have a remainder of 0. What do we have left for the quotient? Again, this is my constant. This would be x. This would be x squared. So my answer is I have an x squared plus 7x minus 8. Does that make sense? What does it tell me if dividing by x minus 7 gave me a remainder of 0? It's a factor. X minus 7 would be a factor. The x squared plus 7x minus 8 would be the other factor. Does that make sense? All right. Have to have a word problem in there. Just for Colin. He likes word problems. The polynomial x cubed plus 7x squared minus 38x minus 240 expresses the volume in cubic inches for the shadow box shown. How do we find the volume of a box again? All right. So if I know the volume is x cubed plus 7x squared minus 38x minus 240, and in my picture here, I'm given a width of x plus 5. What happens if I divide out the x plus 5? Well, it's like saying I'm going to take volume and I'm going to divide out the width. Yes? What would be left? The length times the height. So when I do this division problem, what I have left will be the length times the height piece. Okay? Can we do this synthetically? Yes. What would go in front? A negative 5. Good. And what goes in my first row of numbers? Okay. I wasn't missing any terms, so I don't need any zeros. All right. Bring down our 1 and multiply. Our next number should be a 2. Yes? All right. Multiplying the negative 5 times the 2, we get negative 10. Adding my column, we end up with negative 48. What's negative 48 times negative 5? 240, which means I have a remainder of 0. Should I have known that would happen? Yes. If I found volume by taking length times width times height, and I divide out one of those dimensions, it has to go in evenly because it was one of the factors I used to create the polynomial in the first place. So I should know that I get a 0 there. Just a little heads up, if you're working through a question and you didn't get a 0, and you should have, you know you did something wrong with your numbers. Okay? Now, that only works when it was a factor, correct? Okay. So, I have no remainder. The negative 48 would be the constant. Then 2 would be the x's, and the 1 would be the x squareds. So, when I do this division problem, I ended up with 1x squared plus 2x minus 48. We said that would be the length and the height, the other two dimensions that are left over. Can you factor that? What does this factor into? All right, I heard x minus 6 and x plus 8. Okay. Now, part of the question, it did say that they want the length to be bigger than the height. So if I had to define each of these pieces, this would be my length and this would be my height. Okay? And this was my width over here, the x plus 5. So I have found all the dimensions. Part B says, what if we know the width of the box is 15 inches? What are the other two dimensions? Now be careful, because they're telling me this 15 is this width. That means 15 is equal to x plus 5. So my x is only 10. And now if I know x to be 10, can I find the length and the height? If I plug a 10 back in here, right, the length would be 18 inches, and the height would be 4 inches. Does that make sense? As we go through the next few days, you're going to see a lot of examples of this, where we are given or can find one of the factors, and we use that to help us break it down into something we do know how to factor. So go back and look at the original polynomial they gave us for volume. This has 4 terms. The only kind of factoring pattern we had for 4 terms was grouping. Would that work to factor by grouping? If I take out an x squared from the first part, I'd have an x plus 7. Am I going to be able to get an x plus 7 over here? Okay, so it didn't work by grouping. But by knowing the one factor, they gave me the first one, I could use it to get down to a quadratic that we know how to factor. Does that make sense? All right. The last piece uses something called this remainder theorem. It says if you divide a polynomial p of x of degree 1 or higher by a linear expression x minus a, then the remainder is equal to p of a. Now, what does that mean? Let's say I have a polynomial. We'll just say we're adding 7, x plus 7. Okay? If I said find p of 2, what would you do? Yeah, plug a 2 in for x. 2 plus 7, we would get 9. If I said find p of 5, you'd put a 5 in there for x, yes? For a small polynomial like x plus 7, that's not hard to do, right? We're all gifted, right? We can add 7. But we are going to be dealing with polynomials that are much bigger, have a higher degree, that might have many, many terms. And to physically plug a number in, raise it to the powers, multiply the coefficient to it, add all those pieces together can be time consuming. Okay? We can use the synthetic process to make this easy. The theorem says if we take some polynomial and divide by x minus a, so we're going to have p of x, right? We're going to divide by x minus a, which means we're going to put an a in front. What we get down here for our remainder is the answer to that. The other numbers in that bottom row aren't going to matter for this question. The question is not to divide the polynomials, it's to find p of a. And p of a is just the remainder piece. Okay? So, if I give you p of x equals x to the 5th minus 2x cubed minus x squared plus 2, and I want you to find p of 3, am I missing any terms? Yes. So I have 1 for my x to the 5ths. I don't have any x to the 4th, so I need a 0. I do have some x cubes, negative 2 of them. I have some x squareds, negative 1 of those. Do I have any x's? So I need another 0, and then I need my constant. Okay? Yesterday with long division, I said the most common mistake was in that subtraction step. Here, the most common mistake is the number you put out front. The ones we've done so far today, I've given you x minus a. I've given you the factor or the expression that I'm trying to check if it's a factor. In this question, they're not giving that to you. They're saying find p of a. That means we're dividing by x minus a. So here they're saying find p of 3, which means I'm really dividing by x minus 3. Does that make sense? So the number that goes in front is just the 3. Yes? So if I give you x minus a, you got to change the sign. Just put the positive or the the A piece down there. If they are giving you P of A, you already got your A. Nothing to change. All right, let's go ahead and do our division. We bring down our 1. What's our next step? Multiply. 3 times 1 is 3. We write that in the next column, and then we do what? Add. We have a positive 3. Then we do what? Okay, multiply 3 times 3, we get 9. Adding, we get 7. Multiplying 3 times 7, 21. Adding, we get a 20. Multiplying 3 times 20 is 60. Adding it to 0, still 60. 3 times 60 is 180. Adding, we get 180. Adding, we get 182. Okay, what's my answer? 182. P of 3 is simply the remainder, which in this case is 182. That means if I had dumped a 3 in there, raised it to the 5th power, dumped a 3 in and cubed it, times it by the negative 2, if I had dumped it into this, I would have gotten 182 for an answer. Okay? All right, you guys try the next one. All right, let's check what we did for this last one here. What number goes in front? Negative 4. Somebody else, give me the coefficients that I need. 1, negative 3, negative 28, 0, 5, and 20. All right, bringing down our 1, multiplying, and then adding. Multiplying, adding. Multiplying, adding. Multiplying, adding. Multiplying, adding. So P of negative 4 is 0. And because my remainder was 0, what does that tell me? That what would be a factor? If negative 4 is the 0, right? It gave me a remainder of nothing. X plus 4 would be a factor of that original polynomial. Okay? So as we go on to the next few days, we're going to use that idea to help us get things factored and find all those zeros. Okay? So our objectives over the last 2 days, to learn long division and synthetic division. How do we feel about it? Fantastic? I could put 20 million of them on your test and you could whip them out real quick? Yes? Maybe not the long division one so fast? Okay. Homework, page 308. You're doing 21 to 39 odd, 41 and 42, 49 and 50. I would recommend looking at question 42. There were a lot of questions about that earlier today. Also, we've been talking about putting zeros in for missing terms. What if your constant is missing? You still have to put a 0 there. Okay? Otherwise, you're ending one row or one column too fast. So on this last problem here, if we hadn't gotten that last column in, we would have said our remainder was 60. Does that make sense? So you have to have that space in there. All right.